So example number 2, I recopied the setup. We have to write it in ascending order. And if something's missing, we have to add a 0. So there's a setup again. This one, all right, I'm dividing by x plus 2. It looks like it's in the right order. This is the biggest one, then a minus x cubed. And then I notice there's no x squared. So in the setup where I said if a degree is missing, add a 0. So I'm going to add 0x squareds. The rest of it was written nicely in order. But I had to include the 0. And we'll see why that 0 is important. And if you don't write it, sometimes it messes you up a little bit. Okay? So, same process. My first number, 3x to the 4. What would I have to multiply x by to get 3x to the 4? I'd have to multiply by a 3x cubed. And I write that above my x cubed column. 3x cubed times x, of course, is 3x to the 4, and 3x cubed times a plus 2 is plus 6x cubed. I put it in brackets and subtract, and I get 0. Negative minus 6 is negative 7x cubed, and everything else, the 0x squared, the 3x, and the 20 can just come down. Now I have a minus 7x cubed. What would I multiply x by to get a minus 7x cubed? A minus 7x squared. So one of the reasons we write the 0 in is because we will get x squared in our answer, and we sort of need that column there. And we also need that column there when we multiply this out. I'm going to get minus 7x cubed. Minus 7 times 2, minus 14x squared. And subtract, this will be 0. 0 minus a negative. That 0 is important there so that you get the right number when you subtract. 3x minus nothing, minus 20 minus nothing. My new first term is a 14x squared. What can I multiply 14x squared by? After I multiply the x by to get 14x squared, I need a plus 14x. 14x times x, 14x squared. 14x times 2, plus 28x. Put it in brackets and subtract. That'll be 0. 3 minus 28, negative 25, minus 20. Oh, I have to switch to a new color. I'm going to go blue. My new term is minus 25x. What could I multiply x by to get minus 25x? Minus 25. Will give me minus 25x, and minus 25 times 2, minus 50. If you're going to make a mental math error, it's usually in the remainder. People get so excited about being done the question that they usually make a mistake in subtracting the last one. Negative 20 minus a negative 50 will be add 50 will be 30. That is my remainder. A remainder of 30. Now, just like we did for the first question, we're going to write out what this answer means. But before we do that, they have formally done this on the page before. So I'm going to get you to turn to page, well, you don't have to turn, it's just look at page 4 at the box where it says division statement. And the division statement looks like this. You always take your original polynomial, which we'll call d. It's going to equal whatever you divided by. Now, when you divide something, the answer you get when dividing is called a quotient. So the answer, which is on top of that long division, is your quotient plus your remainder. So your polynomial is equal to d cubed. do like Dairy Queen. Plus your remainder. And we've been doing this all the way through, right? If you look at example 1, oh, this is example 2. If you look at example 1, sure enough, right here, we wrote, this is the polynomial, this is what we divided by, this is what we got when we divided, and those two are multiplied together, and then we added here our remainder at the end. So we're going to write our division statement because it says write the division statement. But I'm going to show you a little shortcut that you can do to make your life a little bit easier. I like to go to the original equation and put brackets around my original thing. And above it, I like to write let P of X equal that. Because our division statement that we want to write is supposed to be this, right? Dairy Queen plus remainder. I seriously think Dairy Queen should probably give me free ice creams for all this advertisement. And because we said let P of X equal up there, it just means that I'm able to do this instead of rewriting all of that. And this makes me happy because I'm lazy, right? So P of X equals, well, what did we divide by? We divided by X plus 2. What did we get as our quotient? We got 3x cubed minus 7x squared plus 14x minus 25. That is our quotient. And our remainder was a positive 30, so we go plus 30 in the end. This is our division statement. And anytime you write a division statement and your remainder is 0, you have started the process of factoring. If the remainder isn't 0, you haven't started the process of factoring because it didn't work. So that's one of the things that we're going to be moving towards. The curriculum that you guys are doing has been in place since 2009. In 2008, long division used to be in grade 10 pre-calculus. They moved it from grade 10 pre-calculus to grade 12. Are the steps very hard? Can you see, like, could you have probably done this in grade 10? Yeah, it's not too crazy. So this was grade 10 pre-calculus, and in grade 10 pre-calculus, you would have done this a lot. Then, okay, what I'm going to do next here, I've got to, it's going to take a little bit of trickiness. No, that's not what I'm going to do. I'm going to take my division statement, group it together. This I just want I want to take our whole long division that we did here. See if I can do that all in one thing. Oh, yes. Group that together. I'm going to just shrink it a little bit. Can you still see it there? Okay. This is going to be the setup for example 3. Okay. And I'm going to introduce to you something that used to be in the grade 11 pre-calculus curriculum. Okay, our next topic used to be in grade 11, pre-2009. Long division used to be in grade 10. Okay, In grade 11, they showed students another way they could do this same question. I am not going to explain it to you at all. You just have to watch and go, what the heck just happened? That's your job. Either way, I'm going to scroll down. I'm going to bring up our answer. This is the answer to the long division. This is the division statement. We did the long division all pretty colors. Right. Just a little stretch before I do this. Okay. Are you ready? I'm going to get that same answer just a little bit quicker. See if you can figure out what I'm doing. Okay. Oops. Oh my goodness. That's supposed to be this. Hey, I got all the same numbers. 3 minus 7, 14 minus 25. I even got, oh, it kind of disappeared when I erased. I even got the same remainder. And I wrote a whole lot less. Did you see where I got the black numbers from? Okay. Mathematicians, I've told you this already, we're inherently lazy people. So if we can find a shortcut for something, we like to do. The first lazy thing that mathematicians do, this is called synthetic division. The first lazy thing that mathematicians did here is they said, it's kind of annoying to write the x4, x cubed, x squared, x all the time. So if I just don't write it, but keep them spaced out in the right order, right? This is how many x4, this is how many x cubed, this is how many x squared, this is how many x's, and this is how many constants I have. By having them in the right spots, again, setup is important. Has to be descending order, have to add zeros if they're missing. That's a little bit short. The next thing mathematicians did was the number on the outside. Where did I get the -2 from?
You know what your x value was?
Yeah, I have x plus 2 here. And the reason they wrote -2 instead of +2, the number one place where students make mistakes in long division is with subtracting. I don't know, subtracting with the brackets, mental math errors galore. Do you know that you make more mental math errors on average subtracting than you do adding? Adding is a little bit easier than subtracting. So by changing the sign out front, did you notice that in each of the columns I added instead of subtracted? So when I change this to -2, I just bring down the 3. -2 times 3 is -6. I just added. Then -2 times -7 is +14. I just added. -2 times 14, -28. I just added. And -2 times -25 is 50. I just added. So it allows you to add instead of subtracting if you change the sign on the front. And then you get the answers right away. So now in our current curriculum, I taught you long division today. And in the same day I taught you synthetic division and you learned the shortcut. The shortcut only works if you have x plus something, x minus something. Anything else, you still need long division. But way back in 2008, students had to go a whole year only knowing the long way. And they didn't get the shortcut till a year later. Is that a little bit mean? Not like once you get the shortcut, you're gonna find, oh, this is so much better. Anyways, we'll use the shortcut in question 3, but first of all, you can circle 3b and 7.